Hello everyone, welcome to third lecture of the road geometric. Here we will study necessity of curve, horizontal curve, vertical curve, super elevation and transition curve. So what is a curve? Curve is a road geometry which is used to change the direction of vehicle on a road. Means these are two straight road. We introduce a curve to change the direction of vehicle. The necessity of curve is to bring gradual change in direction of motion of the vehicle and to gradual change the grade and for good visibility of the driver. And the major important point of the necessity of curve is to alert the driver so that he may not fall asleep. Then next two type of curve majorly are horizontal curve and vertical curve. If the curve in horizontal direction, this curve is called horizontal curve, and if the curve is in vertical direction, that means in grade, this is called vertical curve or simply gradient. Then different types of curves are simple circular curve, compound curve, reverse curve. This is a simple circular curve, this is a compound curve, this is a reverse curve, this is a spiral curve, this is a Laminscate curve, this is a transitional curve. So these are the definitions of this type of curves, that is simple circular curve, compound curve, reverse curve and transition curve. Simple circular curve is normal to horizontal curve which connect two straight line with a constant radius. That means this radius and this radius are constant, and the making of the arc is known as your curve. This curve is known as simple circular curve, and this curve is in shape of arc of a circle. Then compound curve, if more than two curves are combined, then this type of curve is called compound curve. That curve may have same radius or have different radius. Then reverse curve. Reverse curve forms when two simple circular curves binding in opposite direction are meet at a point, and the point of reverse curvature and the center of both the curve lie on the opposite side of the common tangent. Here is the reverse curve, this is the common tangent, and here is one center, here is other center, and here is one radius, here is one radius, here is one radius, here is one radius. The main important point is the reverse curve have only one common tangent and center is in opposite direction. Next, transition curve. A curve of variable radius means the radius is varied from infinity to required radius, that is called variable radius. A curve with variable radius known as transition curve. It is generally provided on the sides of the circular curve or between tangent and a circular curve and between two curve of compound curve or reverse curve. Means this is the reverse curve and here is the transition curve. Transition curve help gradual introduction centrifugal force by gradual super elevation, which provide comfort to the passenger in the vehicle without sudden jerking. Then here is some example of different type of curve, that is spiral curve and Laminscate curve. Then coming to transition curve. Transition curve, as we have already gone through the definition, now coming through the objective of the transition curve. The objective of transition curve is gradual introduction of centrifugal force, introduction of super elevation, introduction of extra widening. Extra widening means in curve we are providing extra width of the road compared to the existing width, cause during turning the front end of the vehicle will not follow the rear end of the vehicle will not follow the front end of the vehicle. That's why we are providing few extra widening, that is called psychological combination of psychological widening and mechanical widening, and this is called extra widening to provide comfort to the driver and to run the vehicle. and to enhance the aesthetic view of the highway. So the IRC recommend the transition curve should be spiral or clothoid spiral as ideal transition curve because it satisfies the rate of change of centrifugal acceleration, that is length of transition curve into radius is constant. Then the calculation and field implementation of spiral curve is simple and easy, and it enhances aesthetic view also. Next, coming to determination of length of transition curve. How we will determine the length of transition curve in design? So there are three methods. First method is your rate of change of centrifugal acceleration. Second method is rate of change of super elevation, and this method have two method in sub two method. How we are introducing super elevation? As in road geometry, we have already covered the what is super elevation. Super elevation is the raising of outer edge with respect to inner edge, known as super elevation, to counterbalance the effect of centrifugal force. This is your outer edge, this is your inner edge, and this raising is called super elevation. This raising can be done in two types. This is one type, and in second type we can raise the super elevation from the center by raising half and by raising down half. So here is E by 2, here is E by 2. So based on change in centrifugal acceleration, we can say this as two method with respect to center and with respect to edge. Two method. Then last method is IRC formula, and the which in three method there are three length. We will apply the length which will get larger of the three. We will adopt this as our length of transition curve. So here is the first formula for based on change in centrifugal acceleration, that is Ls is equal to Bq upon Cr. Here V is in meter per second. If we convert that velocity to kilometer per hour, then our formula will be 0.0215 Bq upon Cr. If C not given, C is your change in centrifugal acceleration. If C is not given, we can calculate it from the formula 80 by 75 plus V. Here V is in kilometer per hour. These are some empirical formulas to calculate change in centrifugal acceleration. And next, based on rate of change of super elevation, we have two formulas. One is with respect to center and one is with respect to edge. If we consider with respect to center, then formula will be W plus WE E by 2 into N. This is with respect to if the rate of change in super elevation with respect to center. If the with respect to edge, center, with respect to edge, formula will be W plus WE into E into N. N is our gradient, E is our super elevation, W is our extra widening, W is our width of road. Then here is one another method, that is IRC formula. IRC formula is for plain and rolling terrain, that is Ls is equal to 2.7 V square upon R. For mountainous and steep terrain, Ls is V square upon R. Here is an example of calculating. Extra widening. After that, we will calculate the length of transition curve. Then we will move forward to super elevation design. Okay. First, here is the question given. The velocity of vehicle is 80 kmph and in a two-lane road, means number of lane given as 2 lane. Then when a design vehicle with a wheelbase of 6.6 meter, means here is two wheel of the vehicle, the length of vehicle is 6.6 meter. Then negotiating a horizontal curve on the road, off tracking is measured. Off tracking means the extra widening measured 0.096 meter. The required widening on the carriageway of 2 lane, means we will calculate extra widening for 2 lane 2-way road. Okay, here extra widening given 0.096, that means of tracking for a single lane road. From this we will calculate the radius of the curve. As we know, the extra widening formula is mechanical widening plus psychological widening, and mechanical widening is NL square upon 2R and psychological widening is B upon 9.5 root over of R. R is your radius of curve, L is your length of wheelbase, and N is number of lane. As everything is given, we can calculate radius from this formula by adopting N is equal to 1. Then we will calculate extra widening based on this formula, and our extra widening coming is 0.75 meter. Okay, next coming to this question for design of transition curve. Here is a question, design of transition curve. So the question is, a 2-lane pavement in a plain terrain with an extra widening of 0.2 meter, that means W given 0.2 meter, is provided on a horizontal curve of radius 200 meter. The allowable rate of change of super elevation means C given 0.6 meter per second cube. Then allowable rate of change in super elevation 1 by n given as 1 by 100, and speed V given as V given as 60 kmph. The pavement is rotated about its inner edge, means we will consider full super elevation, not half. We have to calculate the length of the transition curve and value of shift in meter. The the formula for shift in meter is L square upon 24R. Then we will calculate first the length of transition curve based on rate of change of super elevation. So first formula is rate of change of super elevation. So L is 0.0215, as I am considering V is in kilometer per hour, by C into R. So applying everything, we have calculated the length as 38.7 meter. By applying second formula, length of transition curve LS is equal to E into N W up plus WE. So everything given, E given as 0.07. If not given, we will consider it as 7% for analysis question, and for design question we will consider it as mixed traffic condition into N 100 into extra widening given as 0.2 meter and width of road given as 7 meter, and calculating all, the length is 48.6 meter. Then by using IRC formula for plain terrain, LS is equal to 2.7 V square upon R. So applying V in kilometer per hour, we have length, calculating length is this length is calculating as 50.4 meter, and for IRC formula the length is 48.6 meter. As I have earlier said that the length of transition curve will be more than 1, 2 or 3, that is 50.4 meter, coming in rate of change of super elevation. Therefore the length of transition curve is taken as 50.4 meter. Then the shift of curve means how much distance the curve will be shifted. This distance is called shift of curve, that is L square upon 24R. Applying this, the curve will be shifted to 0.53 meter from the original position. Okay, coming to second problem. Here is the second question. On a highway, to design this is a design question. As in design question, the design speed is given 80 kmph and radius of curve 1900 meter. no extraordinary means WE is equal to 0, and length width of pavement W given 7 meter. A road is passing through the plain terrain, means terrain given 2 point plain terrain for which IRC formula will be 2.7 v square upon r. Rate of change of super elevation given means 1 by n given 1 by 150. So n is equal to 150. We will calculate, and the pavement is rotated about its center line. If pavement will be rotated about its center line, then super elevation will have. So applying formulas, first formula 0.0215 BQ upon CR. From that we will calculate that the 23.7 meter as length of transition curve. Here C is not given. We will have to calculate C, that is rate of change of super elevation, from the formula 80 by 75 plus B, which is coming out around 0.516 meter per second cube. Then as here no super elevation is given and this is a design question, here we will calculate by considering mixed traffic condition the super elevation. Super elevation is calculated as 0.0316. Then applying this in formula, we will calculate the length of transition curve, that is 16.59 meter, and considering plain terrain as per IRC formula, the length of transition curve coming around 19.2 meter. So here we are getting the transition curve length larger of these three as 23.7 meter, which is coming in rate of change of super elevation, adopting this length as a length of transition curve. Next, coming to super elevation, here is the few drawings about super elevation, how we are introducing super elevation, and what are the formulas. The super elevation already discussed that the raising of outer edge, with respect to inner edge. Here is the inner edge, here is the outer edge. Raising of outer edge with respect to inner edge to counteract the centrifugal force and to balance the transverse friction is known as super elevation. Here is the mechanics. The outer edge with respect to inner edge, here is the angle of super elevation, and here is the centrifugal force which is acting on the vehicle. Here is the centripetal force, that is super elevation force. Next, what is its limit? The limit is in plain terrain it is taken as 7%, and in hilly terrain the limit is 10%, and minimum super elevation will be equal to camber on or cross slope on the road on which we are providing super elevation. We have already discussed camber. Camber is the raising of mid surface of the road to drain off the rainwater. Then here is the derivation for the super elevation. From that we will consider the centrifugal ratio, that is P by W and V square upon GR. Applying mechanics, we will find the relation that E plus F is equal to V square upon 127 R. E is your super elevation, F is your lateral friction taken as 0.15, and V is in kilometer per hour, and R is in meter. And this centrifugal ratio has a effect on the vehicle, that is, we know if E plus F is equal to P by W, if E is 0 means how much the friction on the road so that the vehicle will not overturn and not slide. For that condition, the friction must be greater than P by W and V square upon GR. Here two similar topics, that is slip and skid. What is slip and skid? We can take an example. While we are running on a river sand, our vehicle will slippery, means vehicle will not move forward and running around and the vehicle not running longitudinally and turning that circumferentially. Means here longitudinal movement is less compared to circumferential movement. That condition is called slipping condition. If circumferential movement is not occurring, means vehicle is in very high speed and we are applying sudden brake, that vehicle will not move circumferentially but it will move longitudinally. If circumferential movement is less than longitudinal movement, that condition skid will occur. And if circumferential movement is more than longitudinal movement, on that case slip will occur. I think this can you can remember this thing. In one case circumferential movement is more, in that case slip will occur. In one case longitudinal movement will occur more than circumferential movement, that case skid will occur. Next, P by W and V square upon GR. The tendency of vehicle to overturn and the tendency of vehicle to slide. These two effects we have to consider while design of super elevation. So first condition is overturning effect. If P by W is equal to V by 2H, this condition is equilibrium condition. That means the vehicle will not overturn on the turning. If P by W or V square by GR is more than V by 2H, in that case the vehicle will overturn. If P by W or V square by GR is more than V by 2H, on that case vehicle will overturn. Then if the B by 2H is less than F, on that case the vehicle will overturn first before skidding. Means first overturn, then the vehicle will skid. If F is less than V by 2H, the vehicle will skid, not overturn. Therefore the safe condition for the vehicle that should less than P by W and B by 2H is less than P by W and F is less than B by 2H. Then coming to design of super elevation. So design of super elevation consists of 5 steps. In first step we have to consider the mixed traffic condition. Mixed traffic condition means the design speed will be reduced to 75% of its value. First step. That step we will calculate E is equal to V square upon 225R. If this value is less than 7%, then it is okay. Otherwise we will design the super elevation. Then coming to next step, if E value greater than 7%, if E value greater than 7%, then adopt E is equal to 7% and consider about friction. In third step we will apply the formula E plus F is equal to V square upon 127R. As we know, applied E is equal to 7% means 0.07 maximum super elevation on plain terrain plus F. Here we will calculate the F is equal to V square upon 127R minus 0.07. If this value is less than 0.15 as per IRC, if this value less than 0.15, then the super elevation will be 0.07 and the value of friction will be whatever we calculated. If it is greater than 0.15, then we will limit our speed by considering last step. Last step is our allowable speed on that road. By considering E is at 0.07 and F is maximum at 0.15, we will calculate the limiting speed from the formula VA is equal to 127R into 0.22 square root. Here is few questions, and lastly we will provide the speed limit like this. Here is few examples. Let us solve one example. The radius of curve in a two-lane road, the width design speed of 80 kmph, horizontal radius r is 480 meter, design rate of super elevation means here we have to design rate of super elevation means first of all we have to calculate E is equal to 80 upon 80 square upon 225 pi. Here we will calculate E value, then we will calculate F value, then we will restrict the speed limit. So here are few examples. Then we will study how the take the screenshot of these questions and practice. Here how we will provide super elevation on the road. The super elevation is provided in two methods by providing means shifting of crown and rotation of pavement with to attain full amount of super elevation. Rotation of pavement means what? Rotation of pavement about center or with respect to edge. So elimination of crown means crown is your highest point on the road surface. The road surface crown can be eliminated in these two steps by increasing the edge or by reducing the crown. In these two steps we will eliminate the crown, and by second method by implementing rotation about inner edge or rotation about outer edge or rotation about center. In these three method we will provide super elevation on a road practically. So thank you. This is for the third lecture of the topic. Thanks for watching.